no heat engine operating in a cyclic process between given two thermal reservoirs with fixed temperatures can be more efficient than a reversible engine operating between the same temperature. It is a negative statement. So it states that all engines efficiency operating in a cyclic process between the given temperature reservoirs should be less than the Carnot engine. That is the main definition of this Carnot theorem. No heat engine operating in a cyclic process between the given two thermal reservoirs with the fixed temperatures can be more efficient than a reversible engine operating between the same thermal reservoirs. So meaning that always the Carnot engine efficiency should be greater than any other engine operating between the same temperatures. Okay, right. So here Carnot engine have two corollaries. So first one I already discussed. Okay, so first corollary is all reversible engines operating between the two given thermal reservoirs with fixed temperatures having same efficiency. Let us assume there are two engines are operating between same temperature source and sink. They should have same efficiency. That is the corollary one. Okay, so let us assume same figure only. Let us say E and EB. If you see here, let me take the pen. So we have two engines, EA and EB. Both are the reversible engines. Okay, right. As we know, according to corollary one, any two reversible engines operating between two fixed temperatures, both are operating source T1 and sink T2, should have same efficiency. That is the corollary one. Any heat engine operating between two fixed temperatures should be having same efficiency. Okay, right. So here let us assume we are considering two heat engines, EA and EB, are operating between two thermal reservoirs of same temperature. Source temperature at T1 and sink temperature is at T2, right? So this can be what we call derived, right? We can be prove that. We are assuming EA is more efficient than EB, right? So we are going to make it as false so that we can say that efficiency of EA is equal to efficiency of B. So now we are going to prove this one. So right, these two engines should have same efficiency. That thing we are going to prove. So in order to make this, I am assuming that EA is more efficient than AB. I am assuming that is our assumption only, right? So means EB with lower efficiency is reversed because both are reversible engines. That's what A and AB, right? So both are reversible engines. Therefore, I can reverse any of the engine. So here I am assuming that EB I am making as reverse. When heat engine is reversed, it will be acting as a heat pump or refrigerator. So therefore, so what I am doing, EB I am reversing the direction so that it will operate as either heat pump or refrigerator. Both EA and EB can be coupled and part of work output of engine EA can be used to drive the heat pump, right? So as we know here both we are coupling, right? And let us assume in here EA is reversed, okay? But let us say if EB is reversed, what will happen? Let us assume this is B time being, and this is WB, and this is A. This will become WA minus WB. This is Q minus WA, and this is Q minus WB, right? So EB engine is reversed. Therefore, it will be acting as a heat pump, right? Now, as we know, in order to drive the heat pump, we need to supply the external input. So let us say W is the external input that is extracted from the engine A. This work is extracted from the engine A. Let us assume the engine A is delivering WA work. From this WA work, I am extracting WB. So what is the work left out? WA minus WB. This is the net work available at the engine A. So after extracting B, so therefore this is WA minus WB, right? Q is the heat supplied here, okay? Q is the heat supplied and WA is the work done by actual work is WA, but from that WA, some portion of the work is used to drive the pump. So therefore, let that portion will be WB, then the left out will be WA minus WB, right? When from the Q, WA is the work converted, therefore what is the left out? Q minus WA will be rejected to the sink. Okay, now so this pump is taking the heat from the reservoir at a T2. So let us say it is extracting Q minus WB, and in order to do that, WB is the work required. So if you draw the energy balance for the pump, these two are going into the engine and this is coming out of the pump, sorry, here pump, right? So when these two are going, let us say Q minus WB plus WB Q, so this is equal to Q, the energy balanced. Okay, now for this composite system, if you see, this engine is extracting of Q amount of heat from the reservoir and this pump is delivering Q amount of heat to the reservoir. So therefore I can bypass this reservoir by coupling these two. I can bypass this reservoir by coupling these two. Therefore, so now if you see, these two engines are operating with single thermal reservoir, right? So this is according to the first law of thermodynamics, but it is violating the second law as a Kelvin Planck statement. Therefore, the assumption we are assumed, let us say EA efficiency of engine is greater than B, is wrong. Therefore, I can say that both the engines are having same efficiency, EA equal to EB. Okay, this is what about the corollary one. That's what all reversible engines operating between the same thermal reservoirs will be having same efficiency. Okay, now corollary 2 will be, right, so the efficiency of any heat engine operating between the two thermal reservoirs is independent of the working fluid. Whatever the fluid, it won't bother, but depends only on the temperature of the reservoirs. Okay, now so corollary 1 is all heat engines, all reversible engines operating between fixed thermal reservoirs and fixed temperature, right? So they are having same efficiency. Second one is the efficiency is independent of the working fluid, but it depends only on the temperature. Okay, we are going to prove this one, right? So let us consider here for the second corollary. Okay, so let a Carnot engine E and pump P, okay, are operate between two thermal reservoirs at T1 and T2, right? As we know, the engine will deliver the work. Let us say W is the work done by the engine, right? And in order to run the pump, we need to supply the work. Okay, right? So as we can explain, if E is operating between T1 and T2, and P is also operating between T2 and T1, because P is extracting heat from the lower temperature body and it is delivering to the higher temperature body, right? Now, so here what we can say that the Carnot pump is reversed Carnot engine. Its work and heat interactions will be the same here. Both are having same efficiency. That is the first corollary, right? Both the engines operating between two given reservoirs will be having same efficiency. Here Carnot pump is nothing but the reverse of Carnot engine. So both the directions will be reversed. The pump absorbs Q2 amount of heat here and from reservoir T2, and it will deliver Q1 to the reservoir T1, right? Now if you see here, if you coupled these two, if you let us assume my engine is giving more work than the pump required. Let us say here, assuming that my engine work is directly used by the pump. Now I am assuming that this engine is delivering more amount of work, therefore part of the work is used to dry the pump, remaining work I am extracting out. Okay, right? So the part of the apart from now, so what we are assuming now, if you see, both are having same efficiency according to corollary 1. What is the network here? Network will be 0 because the work done by the engine is used to dry the pump. So therefore W net will be 0 in first figure. W net will be 0. Now in second case, what I am assuming, that my engine is delivering more work than the pump. Therefore only part of the work delivered by the engine will be used by the pump. Remaining is excess I am extracting. Okay, so let us assume that apart from the temperature limit, the efficiency of machine depends on some other factors. Let us say working fluid. We are assuming that the efficiency not only depends on the temperature difference but also some working fluid. Okay, then what will happen at that time? The engine may deliver more work than the required by the heat pump, because if I change the temperatures, I can increase the work done, because work done equal to 1 minus T2 by T1. That is the formula. Sorry, work done equal to T1 minus T2, right? Heat supplied minus efficiency equal to work done by heat supplied. Work done is equals to T1 minus T2. By changing the temperature, let us assume I am thinking that the efficiency can be increased. So in that case, I am assuming that the efficiency, the engine may deliver more work than the required by the heat pump. That would leads to the arrangement which indicates that no net interaction with the high temperature reservoir. Means here, if you see, this is extracting Q1 amount of heat from the reservoir and it is delivering Q1 amount of heat to the reservoir, right? So therefore, the no net interaction between the heat high temperature reservoir, it supplies and recovers back the same amount of heat. You can see it is supplying Q1 and it is recovering back same Q1, right now. So therefore, now if you see, I can again bypass this reservoir by coupling these two. Again, this is also violation of the Kelvin-Planck statement or second law of thermodynamics. Therefore, the assumption I assumed is wrong. Means what is the assumption I am assuming? The efficiency is also depends upon the working fluid, right? Here, if I consider working fluid, the assumption I am assuming is wrong. Therefore, what is the conclusion? The efficiency is only depends upon the temperatures, not on the working fluid. That is the corollary to the efficiency of heat engine operating between two given thermal reservoirs is independent of the fluid and depends only on the temperature of the reservoirs, right? Here, if you see the combination is PMM2 because it is extracting heat from only one thermal reservoir. Okay, so it is the perpetual motion machine of second kind in violation of the second law. Hence, the assumption that the efficiency of reversible engine depends on a factor other than the temperature difference is wrong. Okay, so with this, the Carnot corollary is over. Now we will see the problem. Okay, so what is the Carnot theorem? No engine efficiency. Remember, no engine efficiency should be more than the Carnot engine. Means whatever the engine we are going to fabricate, that engine efficiency should be less than the Carnot efficiency. Okay, now if you see a problem here, an inverter claims, am I audible?
Yes, sir.
Right. An inverter claims that an engine that operates between the source 450, is this color is visible or can I change to white? Right.
Change color,
So,
sir.
so yeah, white is okay.
Okay, sir.
Is white is okay? Right. So let us say source temperature is 450 Kelvin and sink temperature is 280 Kelvin. So the heat engine is operating between these two temperatures. This is the engine and 450 to 8 and capable of delivering 0.15 kilowatt hour of work. So what is the work delivered? 0.15 units are very important. Kilowatt hour. For every 1200 kilojoules of heat received, what is the Q here? 1200 kilojoules. Right? As a patent officer, would you issue the patent to such engine? Right? Let me change to the paint. Okay. Now, is this color is visible?
Yes, sir. Yes, sir.
Yeah, 450 Kelvin is the source temperature and 280 Kelvin is the sink temperature. In between, an engine he designed, he fabricated or invented, and this is the Q and this is the engine. What is the Q given? I think 1200, right? Q is equals to 1200 kilojoule, 1200 kilojoule, and it is rejecting here. W is equals to point, how much? 0.15 kilowatt hour. 0.15. 0.15 kilowatt hour, right? So what he is saying is this, what is the question? Would you, as a patent officer, would you issue a patent for such engine? Means, so this engine should satisfy the Carnot. In order to exist any engine, that engine should operate, should what we call obey the Carnot principle, right? So what is the Carnot theorem says? All engines efficiency should be less than the Carnot efficiency, right? So we can calculate easily Carnot efficiency, right now. So what is the Carnot efficiency? Tell me. Reversible engines.
1 minus
It is
T2 by T1.
one minus T2 by T1. Very good. Yeah, 1 minus T2 by lying here. Let me change the connection. Right, and can anyone operate T2 how much? 280. 1 minus 280 by 450. Please operate the calculator and tell me. How much it will be? 450 minus 280 by 450. So let me try.
0.377, sir.
Very good. 0.377, or I can say it is 37.7 percentage. Means if my engine efficiency is less than this, then it is acceptable. Agree? Yes or no? If
Yes.
this if this engine efficiency is less than this, then that is acceptable, or else it is not acceptable, right? Now we will calculate the work done by using this heat and everything, right? So first we will convert the units. Work is given as 0.15. So we'll convert to kilojoules, right? Kilowatt means what can write? Kilowatt is equals to kilojoule per
36 into
second into hour is
kilowatt
nothing
hours.
but 3600 second. So therefore it will become joule. How much it will be? Tell me, operate and tell me. 0.15 into 3600, around will get 500 and how much? Yeah, 540 will get it. Okay, 540 kilojoule, right now? Right. So what is the heat supplied? Q supplied is equals to Q1. This is Q1. This is also kilojoules. So therefore units are balanced. That's why I converted kilowatt hour to kilojoule. 1200 kilojoule. Now, how to calculate the efficiency? Efficiency is efficiency of the engine. My engine is equals to work done.
Work done by each supplier.
Heat supplied 540 by 1200 into 100. How much this value? Tell me. How much this value?
0.45, sir.
Means into 100 means 45%. So this engine efficiency I am getting is more than Carnot engine efficiency. Is this is possible? Is this is
No, sir.
possible? No, not possible. Means since no engine can be more efficient than a reversible engine. So therefore the claim is false and patent is not issued. Right now? No engine can be more efficient than reversed engine. More efficient than reversed engine. So patent can't be issued. That is the statement you need to write. Patent can't be issued. Clear na? This is the first problem. Now, next problem. An engine manufacturer claims to have developed a heat engine with the following specifications. Okay, na? Let me copy this question to this one. Control C. Right. This is the question is visible?
Yes, sir. Yes,
Right.
sir.
Now, an engine manufacturer claims to have developed heat engine with the following specifications. Power developed is nothing but work done per time. Okay, na? Right now. So power developed is nothing but work done only. How much given? Work done is equals to 75 kilowatt. Kilowatt is nothing but kilojoules per second. 75 kilojoule per second. The fuel burnt is given, right now. Mass of fuel is given. Fuel burnt, mass of fuel. Okay, mass of fuel is how much? 5 kilojoule per hour. So mass should be always in kg, right now. So maybe this is wrong. 5 kg per hour. Let us assume kg per hour. Per hour we are burning 5 kg of the fuel, and heating value nothing but calorific value. Heating value is nothing but calorific value is equals to 75,000
Kilojoules per
kilojoules per kg. Then temperature limits means source is given as 1000 Kelvin.
T1, T2.
Yeah, T1, and T2 is equals to 400 Kelvin. Here the engine, and this is, yeah, ask me.
How did you find calorific value, sir?
Calorific value is given. in the problem. Heating value is nothing but if you burned what is the unit for calorific kilojoules per kg, right now? Right. If you burn 1 kg of fuel, what is the heat liberated? That is meaning of its calorific value.
Oh,
The
yes, sir.
amount of heat
Understood.
liberated by burning a fuel of mass 1 kg is called its calorific value. Okay. It is given in the problem. Heating value, other name is calorific value. Okay. Now, 1000 Kelvin and 400 Kelvin, this is the work done. This is the engine, right? Is the claim of the manufacturer is true or false? Give your reasons, right? Now, so work done is given kilojoules per second, and mass of the fuel is also given, right? How to calculate heat supplied? Q is equals to mass into calorific value, mass of fuel burnt into calorific value. So kilojoules kg per hour and kilojoules per kg. What are the units you are getting? 5 into 75,000. How much it will be?
Kilojoules per
Units will
kg.
be kg cancel kilojoule per hour, right? Yes or no?
We should convert
The
it into
the
second.
units yeah, the unit we are getting is kilojoules per hour. So whatever the value you are getting, you should divide with 3,600. Agree? Then it will
Yes,
be
sir.
converted into kilojoules per second. Tell me, after dividing with 3,600, tell me what is this value? Two zeros will gone, and 5 into 75 by 36.
104.1.
104.1
Once.
kilojoules per second. Both the units are same. Okay, right. Now first we will calculate Carnot efficiency. Okay. So efficiency of reversed Carnot is equals to 1 minus T2 by
T2 by
T1.
T1.
T1. Right. Always the efficiency should be less than this. We should get. Then only it is correct. 1 minus 400 by 1000. So 600 by 1000. 6 by 10.
Yes,
6 by
0.4.
10 means
0.6.
how much it will be? Means it will become
0.
60%. That's certain, right? 0.6 means 60%.
60%. Yes.
Okay. Now, so here now we have work done and we have heat supplied for this engine, right? Now, how to get the efficiency of the engine? Work done by heat supplied. So work done. Both units are same, right now? Work done by heat supplied. Work done is we calculated 75 kilojoules per second. Work done is 75 kilojoules per second by heat supplied is also in same unit. So 104.1 into 100. How much this value? Tell me.
72%.
72%. Again, it is also greater than 60%.
60%.
This is also violating the Carnot principle. Yes or no? So the
Yes, sir.
Yes, sir.
manufacturer claims the efficiency greater than the Carnot efficiency. So therefore, the claim is false. Right now, the patent cannot be issued to this engine. Clear now?
Yes.
Right. Next. Right. Next, we have classes inequality. How many students are there so far?
14.
14. Okay, we will continue. No issue. Right. Classes inequality. Right now. So this he already we studied in second law. What is the second law of second law thermodynamics? One is the Kelvin Planck statement. Other one is the classes statement. Yes or no? Can anyone remember
Yes,
Yes,
sir.
what is the Kelvin Planck statement? Tell me anyone. What is Kelvin Planck statement? Try to recall Kelvin Planck statement. Hmm? Anyone?
So receiving heat from a single reservoir and convert it into equal amount of work, sir.
Very good, very good. Right now, means it is impossible to construct an engine that operates in a cycle and produces no effect other than work output and exchange of heat with a single heat reservoir. Right now, see exchanging the heat with single reservoir is not possible. That is a Kelvin Planck statement. What is the next statement of second law? Class statement. Anyone please tell me.
Heat cannot flow from a body at low temperature to a body at high temperature. Some
Yes,
work
without
should
any
be supplied to it.
yes, very good. It is also negative statement. It is impossible to construct a device that operate in a cycle and produces no effect other than transfer of heat from a lower temperature of body to the higher temperature body. But in order to occur this one, we need to supply some external work, then only it is possible, right now. Those are the second law of thermodynamics, right now. Right now, if you see here, we already studied if you how to calculate the efficiency of the reversible heat engine. Okay, now just go through the slide here. Right, an efficiency of reverse engine is given by this thing is known to you, right now. Q1 minus Q2 by Q1, where Q I can written as M into C into T. I think this color is not good. Let me take. So efficiency equal to M into C into T means MC T1 minus MC T2, and we already proved that is equal to 1 minus T2 by T1, right now. So if we equate these two, I can write Q2 by Q1 is equals to, I can write Q2 by Q1 is equals to T2 by T1. Again rearranging this one, take Q1 over here and T2 over here. Q1 by T1 is equals to Q2 by T2, right now. Right, clear this one? Till here it is okay,
Yes.
right now.
Yes, sir.
So yeah, this is the heat engine, this is the source, and this is the sink. This engine is extracting Q1 amount of heat, and a portion of the heat, what we call, is converted into the work, and remaining heat is rejected into the sink. What is the W here? W is equals to Q1 minus Q2. Agree here, right now. Here work done is equals to what? Work done is equals to Q1 minus Q2. Yes or no? Q1 is the heat absorbing, heat extracting from the source, and Q1 minus Q2 is the work done by the system, and Q2 is the heat rejected to the sink. Okay, right. Q1 is the heat extracted and Q2 is the heat rejected, right? Now, what is the convention for the heat? What is the sign convention for the heat? Heat added to the system is
Positives.
positive, and heat rejected from the system is negative. Means here, if you take, this is my system heat engine, Q1 will become positive and Q2 will become negative, right now. So by using the sign convention, right, if you write this equation, what will get? If you write Q1 by T1 minus Q2 by T2 is equal to 0, normal equation. By considering the signs of the heat, Q1 is positive, Q2 is negative, negative will become positive. Therefore Q1 by T1 plus Q2 by T2 is equals to 0. What is Q1? Q1 is the heat extracted from the source and at temperature T1, and T2 is the temperature of the sink, and Q2 is the heat rejected, right? So in the summation form, I can write summation of Q by T is equals to 0. Summation of Q by T is equals to 0. So this is the applicable for reversible engine. Summation of Q by T equals 0. Very, very important relation. So again, we are going to define in next topic entropy. Entropy will come from here only. Okay. So for reversible process, summation of heat to the temperature is equal to 0. Clear this one? This is for
Yes, sir.
this is for reversible engine. Again, I am telling, this is for reversible engine, means this engine I can use either engine or pump or refrigerator. So for reversible engine, this is the condition is for reversible engine. For reversible engine, summation of Q by T equal to 0. Okay, now we will see for irreversible engine. Okay, so now let us say always we know the efficiency of irreversible engine is less than reversible engine. Yes or no? The efficiency of irreversible engine is lower than reversible engine. Okay, now let us assume, observe this figure carefully. Let this heat engine is irreversible engine. Okay, means I can't operate this as the pump or refrigerator. This irreversible engine is extracting Q1 amount of heat from the source, and it is doing certain work, right? Now this is the WIRR, is the irreversible work. Always this work will be less than reversible work. Agree? This work will be less than reversible work. Now I have one doubt here. Okay, observe carefully. It is flowing. Okay. T1, T2, This is engine extracting. This is, let us say, this is a reversible engine. Okay, let us say same T1, T2. This is my engine. Okay, so this is irreversible engine. Irreversible engine, right? So let us say for both the engines, I am giving 1000 kilojoules of heat, and here also I am giving 1000 kilojoules of heat. Let us assume both are at same temperature, 400 and 100 sink. Here sink is 100 and this is the 400, right? Now this is reversible engine W, work done by reversible, and this is W done, work done by irreversible. This is W reversible, right? Now according to Carnot cycle, always reversible engine should be having more efficiency, right? Now what is efficiency? Efficiency is equals to work done by heat supplied, right? So for both the engines I supplied same heat. Now in order to get more efficiency, work done should also more, yes or no? If work done is more, efficiency is more. Agree? Please reply. Very,
Yes,
very
sir.
important concept. Means here this is my reversible engine and this is my irreversible engine, right? Now means according to Carnot theorem, WR should be greater than W irreversible. Yes or no? Reversible engine efficiency should be greater than more efficient. What is the meaning of this one? This engine can convert more amount of heat into work. Agree? This engine can convert more amount of heat into work. Let us assume if this engine converts 700 kilojoules of heat into work out of 1000 kilojoule, if this engine converts 700 kilojoules of heat, will this engine converts greater than 700 or less than 700? Irreversible engine.
Less than less than 700.
Less than, right? It may be 600 or 500. Agree? Please answer my question. Is it is clear? If it is 700, it should be less than 700. Okay. Reply, please.
Yes, sir.
Yes, sir.
Right. Now, in this first case, tell me, in this first case, what is Q2 heat rejected to the sink? Is it is 300 kilojoule? And in case of the second case, the heat rejected is 400 kilojoules. 400 kilojoules means
Yes.
from these two we can conclude that if work done is more, heat rejection is less, and if work done is less, heat rejection is more. Agree?
Yes, sir.
Now come to our slide.
Yes.
Now here, now so let us say dash is suffix for the irreversible engine. I am using Q2 dash. Yes, now Q2 dash will be greater than Q2. Agree now? Just now I said.
Yes.
What is Q2
Yes.
dash? Q2 dash is the heat rejected by irreversible engine. Q2 is the heat rejected by reversible engine, right? Always Q2 dash is more because the work done by the irreversible engine is less than reversible engine. If work done is less, wastage is more. That is Q2 dash is more. That's what. So Q1 minus Q2 dash is less than T1 minus T2 by T1, right? Now from this I can write Q1 by Q1 is 1 minus like this. Okay. Now,
Okay.
right. Okay. From this, now if you see Q2 dash, now look here. I want this one. Is this step is clear? You should get doubt. Is this, observe carefully. I'll write in the paint. Right, I'm writing here 1 minus Q2 dash by Q2 is less than 1 minus T2 by T1.
T1.
Okay, yeah, this is T1, right? Sorry. 1 minus Q2 dash by Q1. This is Q1. Okay. Okay, now. Now, so 1 will be cancelled. I can write minus Q2 dash by Q1 is less than minus T2 by T1. Agree?
Yes, sir.
Right. Means here it is like minus 4 is less than minus 2. Is this statement is correct? Which is bigger? Minus 2 is bigger or minus 4 is bigger?
-2 is bigger.
Minus
minus 2 is bigger, right? Negative sign. Now, if I want to remove this minus, is simply if I cancel minus on both the sides, will this equation will satisfy if I write 4 less than 2?
No, sir.
No,
No, for that what I need to do, if I multiply with negative, this
Yes, greater
sign
sign.
will reverse. Yes or no, right? I can write 4 greater than 2. This is correct and this is correct. Agree?
Yes, sir.
In that way, I can write this one as Q2 dash by Q1 is greater than T2 by
2 by
T1.
T1.
Or further, I can write Q2 dash by T2
T2
is greater than Q1 by
Q1 by
T1. T1. Agree?
yes, sir.
Okay. Now come to our slide.
Q2
That's what I
dash by
written here.
T1
Q2 dash by
minus
T2 is
minus
greater than
T2.
Q1. That's what. Okay.
Yes,
No?
sir.
Now, therefore, I can write Q1, and again by considering the sign, Q1 is positive, Q2 is
Minus sign.
negative. Therefore, you will get Q1 by T1 plus Q2 by T2 less than 0. Therefore, summation Q by T, summation Q by T is less than 0 for irreversible engine. This is for irreversible engine, and we already studied for reversible engine it will be what
Equal to
Q2
0.
this
dash
value
is
for equal to 0 means in generalized way I can write sigma q by t less than or equal to 0 means it is for reversible as well as irreversible. If it is reversible I can use equal sign. If it is irreversible I can use less than sign. Okay, right. So here you can write here. So here the subscript r refers to the reversible engine, reversible cycle. Okay, let me take the highlighter. Right. So here right. So R suffix the reversible engine, and the equation is called Clausius theorem. This is sigma Qi by Ti equal to 0. This is for reversible engine. For irreversible engine, I can write sigma Qi by Ti is less than 0, or cyclic integral dou Q by T, because heat is a path function. I can't write D. I should write dou. I already told in the first unit. This is a path function, inexact differential. Dou Q by T is less than 0, and this I suffix the irreversible cycle, and this is called Clausius inequality, where the equation is called Clausius inequality equation is cyclic integral dou q by t is less than 0, and the cyclic integral dou q by 2 is equal to 0 is called Clausius theorem. Means how to define the algebraic sum of, how to define this one, the algebraic sum of dou q by t, that is the heat interaction to the absolute temperature for any reversible heat engine, is always equal to the 0. This is the Clausius theorem, and this can
0.
also be restated as the algebraic sum of dou q by t, that is heat interaction to the absolute temperature for an irreversible process, is less than 0, right? So these two in generalized way, as I told, cyclic integral dou q by t less than or equal to 0 for any engine, right? So for irreversible engine it is less than 0. If you want to
Less
convert
than 0.
irreversible engine to reversible engine, you need to add I is called irreversible, amount by which it is irreversible. You can see here, if I add I to the irreversible engine, it will become reversible engine. The term I indicates the amount by which the given cycle is irreversible. If you add I to the irreversible, it will become equal to 0. That is called irreversible engine. Whereas for reversible cycle, I value is equals to 0. Right? Suppose for any engine, dou q by t is greater than 0, it is violating the second law, nothing but Clausius. Therefore, it is highly impossible. So the only possibility is dou q by t should be either less than 0 or equal to 0. That is the only possible in case of second law of thermodynamics. Okay. So with this, we will stop today. Okay, because second students are less, and
Okay, sir.
second.
Okay, sir.
Any doubts so far? Please tell me. Let me
No, sir.
second.
No, sir.
Sir,
Yeah, tell me.
Durgesh sir posted a timetable saying that there's something like student development program.
Yes, yes, yes.
What is that, sir? Means
Yeah,
Uh,
means they will give training to the regarding to the placement activities. Means let us